Okay, so change of base. If the base is the same, we can just cancel them. So then x would be 8. It's that simple. So we want to get the bases the same. So go to this slide. Do you get that 8 and 4 both kind of come from the same root? They both come from a 2. So the 8 could be 2 to the third to the x equals 4 could be 2 to the second, right? And once I got the bases the same, cancel, cancel. 3x equals 2. It's really easy, right? So then x equals 2/3. Any questions about that? All right, and we're going to try another one. Do you get that both of these come from the same base? What do they come from? Actually, 4 to the something won't give you 32, but 2 to the something would. So they both have a base of 2. Rewrite the 32 as 2 to the something. Rewrite the 4 as 2 to the something. That'll be a little harder. Some of you will have to remember how to handle fractions. How do you make a fraction by changing the exponent? And once they're both rewritten as a 2, then their bases will cancel and the exponents will be equal. Mr. D, tell me what 32 is. 2 to the 1? No, 2 to the 5th. 32 is 2 to the 5th, right? Just means 2 times 2 times 2 times 2 times 2. Okay, and then that equals, and then how do I write that as 2 to the something? Well, 2 to the second would be 4, and that's kind of close, and then it's got to be negative second. That way, it'll make it 1/4. Listening? Please stay focused. All right, this will cancel this, and now I have 5x equals negative 2. And now I can solve for x, and it's super, super easy. Divide by 5, and you're done. Negative 2/5. Okay. Look at these two. What base do they both have and don't say 9? 3. So, if you just had to say 9, didn't you? 3 to the what is 27? Third. And if I could write the 9 as 3 to the something, then I'll be good. 3 to the second would give me 9, and then negative second. And now the bases can cancel. So negative 2x has to equal 3. It's all from there. You getting this? The bases have to match up, otherwise you can't cancel them. So you want to make them match up. There's no e. There's a 3 to the third. How about we just keep doing the math here, Sonny? Next one. Do you get how they both can be written as a 2 to the something? They can. This is testing your ability to handle negatives. Try it. This can be 2 to the something. This can be 2 to the something. One half is 2 to the negative 1, in case you'd forgotten. First you want to match the 2. Like, how do I get 2 to be a 2? 2 to the 1 power. And then it's not really a 2 though, it's the fraction, and that you need the negative form. Okay, so 2 to the negative 1. To the 2x equals 1/4 is 2 to the, I got to match the 4, so I got to use squared. And now that wouldn't work, that'd be 4. So negative. And there we go. Cancel, cancel. No, negative 1 times the 2x. Notice that's in that power to a power position. So that means multiply them. Negative 2x has to equal negative 2. And then divide by negative 2. X equals negative 2 divided by negative 2, which is positive 1. Now here's the way you can check yourself. I think it's 1. And I can move the black box and it says 1. But how do I really check myself? I go back to the original problem. And I stick in a 1 and I see if it works. So I stick a 1 in here. 2 times 1 is 2. Is 1/2 squared really 1/4? Yeah, worked. Okay, next one. This is a little harder because you can't just boil it down to one number. The first thing I'm going to do is make this one flip. Can you see why I'm making that one flip so it matches up better with that other one? All right, so I'm going to make that one flip. So I'm going to say that it's 2 over 5. How do I get something to flip? To the negative 1. Not 2. 2 would square it. I don't want to square it. I just want a negative. Flip it. Then I put it to the x. So far I haven't fixed it, but I'm close. Now can I rewrite that 4 over 25 as somehow 2/5 to the something? Yes, I can. I take out the 4/25s and I put 2/5 to the what? Second. See how the blue thing I wrote is equal to this? That's why I can swap it out like that. I'm taking the one out and putting in the other because they're equal. And now the bases can cancel. Dong, dong, and then I get negative x equals 6. And that's not the answer, though. What's the final answer? X equals negative 6. All right. Raise your hand if you think you're getting this. All right, good. Last one. Same exact thing. If they could both be written as a 2 to a, yeah, I already said it. 2 to a power. If I can write them both as 2 to the something. So this could be 2 to the what? Negative 1. And this could be 2 to the what? To the third. And then the bases can cancel. So 2 to the negative 1 to the x minus 1 equals 2 to the third. And then the 2's cancel. And then it's got to be these guys. That has to equal that. It's just a little longer equation, but you still can solve it like normal. So I'm going to multiply this times this and this times this. That'll be negative x plus 1 equals 3. And then I subtract 1 from both sides. Negative x equals 2. And then x equals negative 2. Raise your hand if you had that one right. All right. Now some of you missed that one. Do you have questions about how that worked? Okay. These might stretch you a little bit, but your homework is just like that. Why don't you go ahead and jump into your homework. We'll stop doing extra practice problems here. And you got the rest of the time to work. Yes? Yes, that answer was negative 2. What? Yeah, hold on.